Two of the following videos are true, while the other one is trash. Can you spot the fake?
Season 4, Episode 5. Round 1, let's begin. This is a rubber mat with a hook attached to it. This metal piece holding the mat in the middle is not magnetic, and you can slide the mat back and forth on a surface. I'm going to use this mat with a pretty large and heavy board. If I put the board flat on the ground, I can place the mat on top of the board and lift the entire board without any glue or adhesive. This is a piezoelectric spark plug. When I press the button, it creates an extremely hot spark between the two wires with a temperature estimated at over 1,000 degrees. You can see it better here in the dark. Nothing really happens when this spark is unconstrained in the air, but if I feed the wires through a film canister cap and then seal it with the base, the extreme heat from the spark rapidly expands the air in the confined space, causing the capsule to shoot up in the air. Here's a bunch of cube magnets stuck together that I'm going to place in this glass. Then I'm going to fill up this container with a bunch of rice. If I rapidly shake the glass up and down, the magnet will slowly rise in the rice despite being much heavier than the rice itself. After shaking it for a while, I can set it down and see that the magnets have risen to the top where I can easily grab them. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Simply pulling up on this mat does allow you to lift quite heavy objects. The rubber mat makes a seal, so when you pull up, a partial vacuum is created between the mat and the wood board, which allows atmospheric air pressure to push on all sides, keeping the objects together. Pulling from the side and the mat easily comes off. Shaking this container of rice up and down does cause the heavier magnets to rise to the top. This is a demonstration of the Brazil nut effect, which is based on how large nuts like Brazil nuts will often rise to the top, while smaller nuts will sink to the bottom in bags when they've been shaken a lot. That means that confining an electric spark like this does not cause the container to shoot up. I actually coated the canister with a bit of acetone. Then when I push the button, the spark ignites the flammable fuel and causes the canister to fly up. Before we move on, I wanted to let you know why I haven't posted these last few months, and that's because I've been working to finish my first ever publicly released video game called Stick Scholars, which is an online social deduction party game where players must parkour to school, answer trivia, and hunt down a hidden class clown who's sabotaging to try and make the entire group fail. You can watch the trailer for all the details, and if you're interested in playing, I'd love for you to wishlist the game on Steam. Thanks for your support, and now on to the next round, round 2. If you take some shampoo and place it upside down on this stand, I can open the cap and squeeze it to let the shampoo fall down. Most of the time, the shampoo just creates a small pile at the base, but occasionally the stream of falling shampoo will jet up into the air quite high. If you place a post-it note with words on it underneath a clear casserole dish, you can read the post-it note through the glass. If I take a bunch of Orbeez which have gotten large by absorbing water over about 6 hours, I can add them to the dish and you can no longer see what's on the post-it note. However, if I add water to these Orbeez to submerge them, and here I'm speeding it up, once the water settles, I can once again read the post-it note and barely see the Orbeez. First up, I used an incredibly strong glue to glue a cube magnet to a popsicle stick, and I also glued a cube magnet to the front of this Hot Wheels car. After waiting for the glue to fully dry, you can see that the magnets are still attracted to each other. I can use this magnetic attraction to store some energy for this car. By taping the popsicle stick to the car such that the magnetic field of the magnets are interfering with each other, as long as I hold it, the energy is stored. But once I drop the car, the front magnet will pull on the car's magnet until the magnetic fields equalize and the car comes to rest. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Adding water to Orbeez does allow you to see through them. You can easily see why using this curved piece of acrylic. Because of the curved surface, the light refracts and doesn't go straight. However, since these balls have absorbed water, they have the same index of refraction as water. So instead of having curved edges on the balls, it basically acts like straight edges, where light does go straight through when looking directly on it. If you thought squeezing a stream of shampoo would cause jets of it to shoot up occasionally, nice job, because this is 100% real and called the K effect. It's quite beautiful to see, especially in slow motion. I tested this out for thin streams and thicker streams, and the thinner to medium-sized ones work the best, while large ones don't really produce the effect. That means you can't use 2 magnets like this to propel a car forward even briefly. Although the magnets do want to come together, any force experienced by one is felt equal and opposite by the other, and they cancel each other out. I originally thought I'd fake this using the remote control since this is an electric Hot Wheels car, but that didn't look very good. So I instead tried to use a magnet to pull it briefly, and that ended poorly after a slight mistake. I did end up using this strategy, but with the magnet underneath the table, although I'm not sure editing it together really fooled anyone. Now it's time for the final round, round 3. This is a metronome, which produces a clicking noise at a specific interval, and here's what that sounds like. If I place several of them on top of a styrofoam plank and start them all, you'll see that they're all out of sync. And even after waiting a while, they stay out of sync. However, if I place this styrofoam board on 2 empty cans so the whole thing can roll back and forth, now when I start all the metronomes, they are originally out of sync, but within 30 seconds or so, they end up completely in sync, as you can see here. If you have a can of food you want to open but no available can opener, here's a trick to open it using a flame and an ice cube. First I remove the label so it doesn't catch on fire. Then I used a lighter to heat up the metal at the seam. Next I immediately quench it with a cold ice cube. I then repeat these steps a few times. The thermal shock between the really hot flame and cold ice cube weakens the metal over time. Within about 3 to 4 cycles, the can is now weak enough at the seam such that I can squeeze it and pop the can open. It does make a mess, but is quite useful. If you take a screwdriver like this and attach a small stack of magnets to the shaft of the screwdriver near the base, you can spin the screwdriver in a circle like this, and the magnets will climb up the shaft until it reaches the top. Interestingly though, if you flip it upside down and do the same thing, spinning from above this time, the magnets will still rise to the top. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Rotating a screwdriver like this with a small stack of magnets attached does cause the magnets to travel upwards regardless of whether you spin it from below or above. I saw this from a Steve Mould video, so check that out to learn more, but it has to do with the way that the magnets slip as they spin. Placing multiple metronomes on a styrofoam block and balancing them on 2 cans does cause them to become synchronized over time. Turns out cycling between a hot flame and cold ice cube on the rim of a can a few times does not allow you to simply pop it open by squeezing. I actually used a combination of extensive sanding and filing to remove material from the lip of the can. Once I felt I had removed enough of the overlapping metal, I then squeezed the can and it popped open. I don't recommend this for pretty obvious reasons where you may end up eating some metal shavings. Here's a quick recap of the final round, and I'll be posting the trailer to Stick Scholars on YouTube shortly, so a link to that will be here when that's up. I'll also link the Steam page in the description where you can find the trailer and more details immediately. Thanks for watching to the end, and I'll see you next time.